Okay, how's everybody today? Good, good, good. Okay, good to see everybody. We'll get started on the focus activity in our next lesson in just a few moments. Remember that in 2 days, the big item is what? Okay, the exam. The exam's coming up. Remember, you can always use your notes on that. Anything you have is going to be fair game. In fact, the first question on the test is going to be very similar to this. The format will be like the quiz we took last week, but you'll have to go ahead and graph one of the trig functions, whether it's tangent, cotangent, secant, or cosecant. Okay, and I thought it would be a good idea. Let's get a little more practice on this before that happens. Now remember, the test is only going to cover all of the aspects of graphing, so you want to know how to find the period, the amplitude, okay, the midline, all that good stuff, and of course graph. All right. Well, let's see. It says 3 tangent of x minus pi over 2. All right, so I want to graph a tangent function. So first thing I'm going to do is start with a compound inequality, and we were talking about this the other day. If it's tangent, what am I going to put as my lower and upper boundaries? Does anybody remember? If I want to create a compound inequality for tangent, what's my lower and upper boundaries? Remember, it was a consecutive pair of asymptotes. Oh, we're close. Now, if you want to graph sine, cosine, secant, or cosecant, we'll put it between 0 and 2 pi. Now we're getting closer. 0 and pi is for cotangent. All right. Deborah says negative pi over 2 and pi over 2. Yes. Do you want me to write the other ones out? No? Yes? Okay. So if you're wanting to graph sine, cosine, cosecant, or secant, you're going to go ahead and say 0 less than or equal to whatever your parentheses is, less than or equal to 2 pi. If you're going to graph cotangent, well, then you want 0 less than or equal to, again, whatever your parentheses are, less than or equal to pi. But if you want to go ahead and graph tangent, then my boundaries have to be negative pi over 2 to pi over 2, a consecutive pair of asymptotes. And I keep saying parentheses, so what am I going to put in there for this one? There you go. Whatever's inside the parentheses, that's what I'm going to put in the middle of this compound inequality. Okay, and I just want to go ahead and simplify this now. All right, well, how am I going to get a single x in the middle? Multiply? We're going to add. There we go. Because see, we're subtracting, so I'm going to do the opposite operation. So I'm going to add pi over 2 to the middle, add pi over 2 to the left, add pi over 2 to the right. Let me go ahead and erase this. Let's see. So what is a negative and a positive pi over 2 going to do? They're going to cancel. 0 is less than or equal to x, less than or equal to pi. There we go. So I've got my compound inequality between 0 and pi. Okay, now let's turn to the critical values. Now, just like sine and cosine, there's going to be 5 critical values, and we didn't really talk about critical values for secant and cosecant because we were graphing the reciprocals, sine and cosine, so we just stuck with those. But when we're talking about one period of tangent, the no solution, what does that refer to graphically? Remember, that's an asymptote. Now, it's got to be one of two things. It's either going to be negative 1, 0, 1, or 1, 0, negative 1. It is going to be, if you're graphing tangent, it's got to be negative 1, 0, 1. If you're graphing cotangent, then it would be 1, 0, negative 1. And I'm still going to end it with a asymptote. Okay. Now, the parentheses go in my compound inequality. That helps me with my x's. Is there anything happening outside the parentheses? There you go. So what am I going to do to every one of those 5? Multiply by 3. So there's no shift here. It is just, or midline shift, vertical shift, I should say. So I want to multiply each of these by 3. Well, undefined times 3 is still undefined. Negative 1 times 3 times 0 and times 1. There we go. And then we have undefined. So those should be my y values. Okay. So I'm going to take out the originals. Those are my new y values after the 3 vertically stretches it. Now, how do I go ahead and put my x's and the y's together so I see the ordered pairs? Okay, so lower boundary goes with the first critical, so that's 0. Upper boundary goes with the last critical. And now, because this bottom one is 0, the distance here is pi. But we always divide by 4. Now, what do I do with that pi over 4? There you go. So 0 plus pi over 4 is pi over 4. Plus pi over 4 is pi over 2. Plus another pi over 4 is 3 pi over 2. And then plus pi over 4 will get you to pi. Did anybody want me to show you those over to the side, like get a common denominator just for the practice, or you feel okay with that? Feel okay? All right. Now, normally we're going to get 5 ordered pairs, like if we graph sine, cosine, secant or cosecant. But with tangent and cotangent, you only have 3 ordered pairs because the other 2, those are your asymptotes. So I know there's got to be an asymptote at 0. So right here down the middle. The other asymptote's where? Pi. Wait. Oh, you're right. Sorry about that. I was just saying if you were paying attention. Obviously you were. Okay. Yeah. Okay, so now pi over 4. So pi over 4 would be here, halfway between 0 and pi over 2, and we have -3. So there's going to be a point right there. Then we have pi over 2, 0, and then we go 3/4 pi right, okay, and then we go up 3. So that should be the graph that I have. And typically, we want at least 1 or 2 other periods if possible. So how can I do that?
Just find out what's in the middle, like those 3.
Yeah. Just kind of copy this right next to it. In fact, where would the next asymptote be? It'd have to be at 2 pi. And then I'd have to have the intercept halfway between, and then halfway between that, I need to go 3 down, and then 3 up. I just copy the pattern. There we go. And I could also do that on the other side as well. Okay. So the first question on your test Friday will be to graph a tangent, a cotangent, secant, or cosecant. One of those 4. Okay. And then the majority of it's going to be multiple choice. And then the last 2, I just put a couple of law of cosines and then law of sines problem on there, just kind of a review. Okay. Any questions on the focus activity? Okay. Now, we are going to be turning these in next week. I haven't decided on what day because I want to go ahead and get another focus activity in. I want you to have 5 for this set. I'm not quite sure if it's going to work out. They're already sending out on email the late start times on Friday, just in case, because some weather apparently is supposed to move in tomorrow night. So if the weather is bad enough we have to delay school on Friday, we'll kind of see what happens. If that does turn out to be the case, then we'll just play it by ear. What's that?
No, I was just saying, I work.
You work tomorrow? Work tomorrow night?
Yeah.
Where do you work again?
Outside, Sonic.
Oh, that's right, Sonic, yeah. That's right. Work outside, yeah.
Keep running out the link.
All right, we'll go ahead and put these with the other 3. You have 4 now. If you have lost or misplaced one, you should be able to look right over here in the filing cabinet and get one. Okay. Well, we are done with the special right triangles for now. I am going to go ahead and stop at 12:15 because I want to go ahead and give you the time in class that we didn't yesterday because I copied the wrong assignment. I do have the right assignment, so I know everybody's really happy about that now. So I'll go ahead and give you time in class to do that. But at the very least, I want to go ahead and give you an introduction to inverses. Okay. We're going to go ahead and start talking about inverse trig functions. Okay, and they're really not bad. In fact, I'm thinking, or at least I'm hoping you guys will think they're a little bit of fun. Well, like all math is fun, right? Of course. So here's the big idea. You guys remember, and this is going back to the first 6 weeks, if we want to take the inverse of a function, we take the x values and the y values and we do what? We switch them. The x's become the y's and the y's become the x's. That's the big idea. So when we're dealing with inverse trig functions, let's kind of go back to the beginning. And it doesn't matter. Give me any of the 6 trig functions. Sine. Let's start with sine. And this applies to all of them. If I want to evaluate a trig function, well, I have to plug in an angle measure. And whether that be degrees or radians, does not matter. Now, if I evaluate a trig function using an angle measure, well, what kind of answer am I going to get? Okay, I'm going to get what? Oh, not radians. No. Something about a triangle. The sides of a triangle. Yeah, you're going to get a ratio. Like in sine's case, you'd be talking about a triangle, the opposite and the hypotenuse, right? So the ratio you get is for whatever that particular triangle is, one side over the other. Now, what we're going to go ahead and start doing is working backwards. We're going to be given the ratio, but we're wanting the angle measure that's created using those links. So in order to work backwards, you have to take the inverse. So I'm going to say sine inverse of the ratio. And what do you think your answer is going to be? In fact, we just said it. An angle. And remember, what did we just say about taking an inverse? We take the x's and the y's and do what? We switch them. And that's exactly what I'm doing here. The angles and the ratios are going to be switched. Okay. The only thing about the inverse trig functions is that they're very particular about what values they like and what values they don't. And that's why we have this information right here. These are properties, and we're going to see as we go along what the ratios are allowed to be and what the angle measures are allowed to be, because you're going to have restrictions on these. Now, these are properties, these are compositions, if you take a trig function and work it with its inverse. Okay, so like for example, okay, sine of sine inverse. Now, what would I put in here? This x right here, does that x represent an angle measure or a ratio? It's a ratio because I'm plugging it into an inverse. You only plug ratios into an inverse trig function. You only plug angles into a normal trig function. Okay, so what this is saying is that whatever that ratio is, that's going to be my answer as long as the ratio belongs to this interval. It has to be between -1 and 1. Okay. So let me give you a couple of statements real quick. And you guys are just going to tell me if they're true or false. If I were to say sine of sine inverse of 2, okay, is equal to 2. And let's say another one, sine of sine inverse of, let's say, 3/4 is equal to 3/4. Okay, one of these is true and one of these is false. Okay, so Brandon is immediately saying the bottom one is true, top one's false. What do you guys think? Okay. Well, let me ask, why is the first one false? Why couldn't that equal 2? There you go. If you're looking at the interval, 2 is larger than 1, right? So see, that rule only applies if x belongs to it. Okay, so this one is false. We can't have it. But the other one's true, because is 3/4 less than 1, but greater than the negative? Yeah, and that's what these are telling you. They're just telling you what the restrictions are, what you can put in, and what kind of answers you're going to get out. Now, the very first day, you're going to look at these, and you're probably thinking, I have no clue where those are coming from, and that's fine. That's normal. Okay, as we go through, I'm going to show you how this works. Okay, so basically today I'll be able to give you a little bit of an introduction, maybe start sine inverse, it depends, and then basically each day we'll look at sine inverse, then cosine inverse, and then tangent inverse, and we'll just take it one day at a time. Okay, so here are some fill in the blanks for us. Remember that a function will have an inverse if it is, what was a phrase we always like to say when dealing with inverses? Not proportion. Not irrational. These are good words, though. Reciprocal. Does anybody remember 1-to-1? You guys remember that? What in the world does 1 to 1 mean? It's even. That means it passes some kind of test. A horizontal line test. Okay, so let me kind of refresh your memory on this real fast. Let's say we have a parabola. Okay, is it a function? Yes, because it passes the vertical line test, right? That vertical line is never going to touch the graph in any two places at once. Okay, but Nathan's already saying it's not 1 to 1. See, he's going to fail the horizontal line test. Okay. If it touches the line in two places or more at any time, it's not 1 to 1. Now, see, this is a big problem for inverses, right? Because this test is going to tell me that there are repeating y values. And remember, what did we say about the x's and the y's when we take the inverse? We switch them. So if we switch the x's and the y's, but I have repeating y's, they become repeating x's. And see, it's not a function. And we really, really like our inverses to be functions. So we talked about restricting the domain so that the graph was 1 to 1. And that's what we're going to have to do with these inverse trig functions. Okay, we want to make sure they're 1 to 1 before we go ahead and invert them. Okay, well, f inverse of f of x equals x for every x in the domain of f, and f of f inverse of x equals x. Remember, that was one of the ways that we tested the two functions were inverses. If we could compose them in both directions and get x, they were going to be inverses. Okay. So let me see if you can help me fill out the rest of this one. The domain, the x's of f would equal the what of the inverse? Remember, what are we doing with the x's and the y's? We're flipping them. So if the x's are the domain, what are the y's? The range. Okay. And the range of f is equal to the domain of the inverse. Okay. So if we were to have something like this, let me go ahead and give you an example. If we had function f with a point, let's say 2, -1, then the inverse, there you go. That's all you do is switch the values. See, I'm not changing their sign. The x becomes the y and vice versa. And this is what it's saying. The domain, the x value of f, is equal to the range, the y value of the inverse. And the range, okay, the y value of f is equal to the domain, the x value of the inverse. That's all that's saying. We're just verbalizing it. Okay. The graph of f and the graph of f inverse are symmetric with respect to the line y equals x. Yes. Remember, the linear parent, that was the line that you would reflect something across in order to see the inverse graphically. In fact, it's been a while, but you guys remember when I showed you that little trick where you take the top left corner and fold it down to the bottom right? Okay. You're folding across that line. There we go. And then if a function y equals f of x has an inverse, the equation of the inverse is we just switch the x and the y. So we say x equals f of y. Okay. But we don't like to write it that way, so we have our notation. Remember, the -1 tells us we're dealing with an inverse. Okay. So I'll tell you what, from here, we would go ahead and start with sine inverse, but I've got 1213, so I'm going to go ahead and stop there. I'm going to go ahead and give you the rest of the period to go ahead and work on your assignment, which is going to be due tomorrow. And with it being just special right triangles, you actually should be able to finish it up before you leave. Okay. So